In this presentation, we're going to be taking a look at different functions and different function operations. So let's suppose we have three functions, f of x, g of x, and h of x. So these three functions are all very different types of functions. They would make different types of graphs, but they're all functions. Depending on the situation, I may want to take two or more functions and compute some sort of operation between them. For example, I may want to take a, f, and h and add them together. And that would give me a brand new function called f plus h of x. It's actually really simple to do, as long as we remember that when we're adding these functions together, we should be careful that we are adding each function in a set of parentheses, and then we're going to go ahead and combine the like terms. So in this case, I don't have any term that's alike with the 4x squared. I don't have any term that is alike with the 3x. I do have two 3x's. So those two 3x's will make 6x. I don't have any term that is alike with the minus 2. So my new function, f plus h of x, is actually equal to 4x squared plus 6x minus 2. Now if I try that again with g plus h of x this time, I would write the 4x squared plus 3x and then add to it negative x plus 4. I'm going to combine my like terms, so I have 4x squared plus 2x plus 4. So that would be my new function. With subtracting, it really becomes important that when we write the two functions with the subtraction sign in between them, we use the parentheses to show that they are separate from each other. Because that subtraction sign in front of the second set of parentheses will need to be distributed to both terms inside that second set. So not only does the 3x become negative, but the negative 2 becomes positive, leaving me with a final function of negative 4x plus 6. So f minus f of h minus f of x is negative 4x plus 6. Similarly, g minus h of x make sure that you distribute that minus sign in front of the second set of parentheses, so that becomes plus x and minus 4, and my final answer, 4x squared plus 4x minus 4. As we move on, things really don't change much. Multiplying f times h of x, we would take 3x minus 2 and multiply it by negative x plus 4. Now what we need to remember here is that this is a binomial multiplied by a binomial, so we would need to FOIL. So negative 3x squared plus 12x plus 2x minus 8, and simplifying like terms, negative 3x squared plus 14x plus 8. There's my new function. Similarly, with the g times h, 4x squared plus 3x multiplied by negative x plus 4. I'll FOIL again. Remember, that's negative 4x cubed, 16x squared minus 3x squared plus 12x, and then that will give me negative 4x cubed plus 13x squared plus 12x as my final answer. Adding, subtracting, multiplying, they all create new functions that are very similar to the old functions in that the domain is unrestricted. The domain of all of the functions previously looked at would be all real numbers. Now when we divide, however, we still divide with the parentheses, 3x minus 2 over negative x plus 4. Now, since I have a binomial divided by another binomial, I really can't just cross out or cancel terms. So my final function is going to be just 3x minus 2 over negative x plus 4. However, I need to focus on my denominator. I have a denominator with an x in it. And we know from earlier this year that there's one thing that a denominator can never, ever, ever equal. And that one thing is a denominator can never equal 0. So if I take negative x plus 4 and say that can't be 0 and try to solve that, just like I normally would, what I discover, and you may have discovered this earlier, is that in order for the denominator to not equal 0, x cannot equal 4. So the domain of f over h of x is all numbers except for 4. And the reason that is because plugging 4 in for x in this new function would give me something divided by 0, and that's just not possible. Let's try that again. This time we'll take g over f of x, which will simply just be 4x squared plus 3x all over 3x minus 2. So the dividing part is very, very easy. But now I need to examine my domain. Again, I have a denominator, and I have an x in my denominator, and that denominator can never equal 0. So I need to take 3x minus 2 and make sure that that does not equal 0. Well, if I add 2 to the other side and then divide by 3, I determine that when x is 2/3, my denominator will equal 0. Therefore, x cannot equal 2 over 3. So my function is fx g over f of x equals 4x squared plus 3x over 3x minus 2, and my domain is all numbers except for 2/3. Again, because when x equals 2/3, my denominator equals 0.